Hello guys, how are you doing? Welcome to the stream. This is me. This is day 11. So what are we doing? So guys, I don't actually have my headphones on and that makes me feel a bit nervous for some reason. As if well, I actually wouldn't feel as nervous if I did have my headphones on. Okay, so let's learn. So what did I do today? Before even before the stream started, I learned stuff. Yes, that's what I did. I learned that for calling convention, and this is about low-level things, and for calling convention on regular user level functions, args as passed as this so they're passed like this. First argument goes to RDI, second is RSI, third is RDX, fourth is RCX, and fifth is R8, sixth is R9. And then from the seventh and above, it's passed into the stack. So that's what I learned. And for syscalls, the RCX is replaced by R10 for args, because like when you call the syscall, it uses the RCX to store the address that you call syscall from so that it can return back. It stores the address of next user level instruction after syscall inside of RCX. That's what it does. Okay. So yeah. Also I think good days are about to happen soon. Although that's vague, I just want to mention it. But yeah, tomorrow might be the last bad day, and then good days will happen. So yeah, and for syscalls, yeah, that's basically all I learned. And caller saved registers. So these are the registers that are saved by the caller, or that could be manipulated by the function, and it just won't care. The function won't care about it. So like you have to save it if you care about the value inside them. So that would be RAX. This is obvious because it's also the return result, and next one will be RDX. Oh, I guess I should go in order. RCX. Next one will be RDX, and then RSI, RDI, and then from R8 to R11, so R9, R10, R11 as well, and Kali saved registers. Kali. That's not how you spell it. Kali. Is that how you do it? No. Called. I'll just do it like that. Kali saved registers. This is a function. The function will save. My point is that the function won't like mess up these registers, so it would be RBX, and that's because the RBX register, it was historically it pointed to like important data and stuff, so it won't mess with it. And RBP, it won't mess with it because that's like the bottom of the stack frame. It will, like, whenever it wants to like mess with it, it will pop it back. And what else is going to what else? Well, I forgot. I didn't forget. I just like from R 12 to I'll just list all of them out. R12 to R15. So R13, R14, and R15. These won't be messed up even after function call. And RSP is like the untouched register. It won't mess it up because it's supposed to be pointing at like at the same space. So it's an untouched register, and it will not be messed up either, because it has to be stored to access color variables after call E returns. Terrible spelling, like you can see all these red stuff. And yeah, that's basically all. Dude, my phone dies like so quickly, and I don't know if I mentioned, but my phone is basically my mic, so yeah. I also plan to, like, because I have I'm not sure whether I mentioned it, but I created like 4 different channels, and I plan to also go in those, because I plan to go in the one for speaking. That's where I learn like speaking stuff, because my English isn't good, so, and basically getting my point across, so that's just gonna help me learn about streaming and stuff. So yeah, I learned this, and then I learned that for XV, or like, nah, that's like anything. 1 equals read perm, or protection. 1 equals read, 2 equals write, 3 equals x, not 3, but 4 equals x. Well, it can be ORed because they are powers of 2. Okay, so, and what else? 0 equals typically standard, and 1 equals typically cd out. 1, 2 equals typically std error. What else? I learned that what is this? 0 syscall 0 equals syscall 0 equals what was it, read, takes in something like fd buffer, red, pointer to a word, red, or no, I could just do red words. This is the buffer to read into, and this is the file descriptor. And write, and 1 equals write, which is also takes in an FD, I'm pretty sure. Takes in a buffer as well. And I guess, I'm not sure about the last one, but dude, my phone is getting like incredibly hot. And if you guys don't know, if all of my 0 viewers don't know, I basically have like one of these like staples. Not that, but what is that? School supplies. Some of these, no. Yeah, I basically have this thing right here, this black thing, and I'm just like holding the phone to my chest by putting this on my phone and my shirt, like making sure both of them are on there. But yeah, Okay, so what was I gonna do? Oh yeah, right. Syscall right. Yeah, so it takes in the count, okay? So first arg is count. So this would be RDI, RSI, and this would be, alright, well, I don't know, wait, let's see. Does it tell me ever on here? For calling convention? Syscall right. Oh yeah, it just takes this, okay. Yeah, it just takes the FD buff and how much to write, okay, yeah, that's the difference. And write bytes. And 2 equals, 2 equals close, takes the FD. I think that's all it takes. Close syscall. Close is a file descriptor. Let's look at that. Yeah, just a FD. Okay. And open also takes it takes a path, I think. It takes a path. Open syscall. And then it takes it returns I think the FD in the EX register. But since this is a syscall, I think the specifics might be different. Let's see, path flags. Oh yeah, flags. Path flags and mode. Path flags and mode. Okay. Yeah, path, flags and mode. Well, what is the flags for? What type of flags are there? Access mode and options. Oh, okay. Specifies if permissions for a new file is used for owner read write. Open syscall mode. I'll create our temp file, okay? Oh, okay. This is it puts in permissions right here. Okay. Wait, what about this open syscall then? Does it already do that? The open file system call path if the does not emit optionally create but in flags. So that's still in flags. What does mode do? Let's see, is my phone dead? Nah, I can still be heard. Before writing, positioned. Oh, okay, this is like modes. It's just like flags, but extended, I guess. Whatever. And I just need to like remember what this is for. Just need to remember like the numbers. 2 equals close, 3 equals open, and now what else? 9 equals mmap, it needs, I'm pretty sure it needs, what's it need? The add 0 for a kernel. Kernel chooses typical. And next one will be mmap. Next one will be length. That's not true. Mmap syscall. Isn't that's one nice did too. Mmap here. Mmap, yeah, it's address, size, protection, mode, I guess. mmap args. What is it called? Flags and file descriptor if you want to map a file, and offset from the file if FD is provided. Okay, so this is this one provides a FD, right? And this one doesn't. Okay, it's a -1 if you don't want to provide a FD. Typical, and then the length in bytes. Length in bytes. The protection. Flex. What else? What was the last one? Not the last one. The second last. Offset. From file. It'll start. Okay. FD equals -1 if no file trying to map, and I can do. So what else did I learn? I learned that just because a memory is allocated that's mapped doesn't mean that it's already there. Physical in physical RAM and its use up. It just means that once you write to it and stuff, for example, you write 1 byte, then the page that contains whole byte is mapped to physical header, in which case then that page is will use physical RAM. Otherwise, other pages won't be touched. Page equals 4 KB or 4 to 96 bytes or 0x1000 bytes. Okay. Oh, that's it's for mmap, and then 10 equals mprotect. I don't need to get to the specifics of that. I can just honestly just get to the specifics of that. Mprotect probably takes the address first, virtual address, and then it takes the size and the prot. Okay. Size and the protection, new protection. Let's see, mprotect. I want to do the Wikipedia that exists. Wiki. The mprotect. No, there's none. address line length and protection. Okay. Get protection of memory in Linux. Mblock. Oh, pmap, permissions of a map. I don't know how this works. It's not that important, I think. Okay, so mprotect it takes in the virtual address and it takes in the length of the address. Mprotect. Oops. Mprotect length. Pages containing the address range. Okay. So it changes the pages. Okay. So even if like I go to 4097 bytes, then it will change the whole, even the page 2's address. Okay. I think that's what that means, because there's no other way that only one byte can be like unprotected. And protect address length protection. And then 33 is equal to dupe 2. It takes in a old FD, new FD, makes new FD point to old FD. Next one is I think like 59, which is XV, and it just takes in the command, or not the command, but executable locate underscore path and environment, or no, args, and then envp, environment variables. Yeah, that's it. Okay. Put a space there. No, don't put a space. Yeah, that's basically all I learned. But okay, so and then I did this. I made like, this is what I did. I think this was like a genius idea for me. So basically, you know how if you ask AI to like make a bunch of like assembly code, so that you can like practice like translating it to C, so that you get better at reverse engineering. Instead of doing that with pure assembly, I just told it to like make a compressed version of assembly. That compressed version is basically, it just maps like it does stuff like this. It just, if it was, for example, like setup, like that might be like a keyword, and that just like pushes what is it, pushes RBP, then it moves ESP to RBP. Or no, it moves RBP to ESP. And basically, like, that's like what you need, right? Oh wait, does it do move RBP and ESP? Or which one does it do? No, it has to be this, because it has to save like the bottom pointer. And I'm also like trying to find an interactable like execution thing, so that like like it's just like it's supposed to execute programs on there, and I'll be able to like see the stack instead of that. I guess you can do the same with GDB, but yeah, I made uh I asked AI to make, and the crazy number is that I asked it to make like 1,000 plus different drills, different assembly drills that are compressed, and mapped a bunch of compressed keys to assembly length. So to x86-64 assembly into assembly length, so that now I can just translate I can just uncompress by giving the key to AI, then giving it drills to uncompress, then copy those into my VM, which is the thing I'm running this on, and then start to translate it into C code. But yeah, this is all I did, and now I'm just gonna save this. And yeah, that's what the first thing we're gonna be doing today. You know, yeah. And I know the setup took kind of long with the obsidian and stuff. But yeah, okay. So we can start doing that. I have to first enable SSH, and I have to do users clear users SA. I'm not sure how to print all users Cali. Command get int passwords. cat slash etc flag. Let's see. This is me. Flat pack is stupid, but okay. Anyways, that's necessary. And my phone is getting like so hot, like on my chest. That's kind of weird, but yeah. What do I, what's the name? Let's go SSH. I think system CTL enable. That's it now. Is that how it works? And perform an action that requires privilege. Okay, do it. Why did it sudo? Okay, should work now. If I do users, okay, so I just have to make like a user add what do I say, like user add copy underscore from desktop, I guess. Yeah. Sudo. And okay. So like what just happened? It's not gonna ask me for a password or anything. SU copy from desktop. Dude, it doesn't have any password. Is that why? No, that's not it. What the wait? Sudo user remove user del copy. Okay, it's add user, I think. Sudo add user from desktop. And it's gonna ask me for a password. Let's make Kelly. None. Yes. Okay, now we have a user now. And let's do this. su copy from desktop Kelly and cd there ls -a. Let's make a cd desktop. I don't know. Okay, there there's files, I guess, and lssa ls-l files lssl ls dash cd files first, ls-l I don't know. Do I need to like cd mkdir? I guess I can just do this. Like, it doesn't matter, I guess. Command prompt. Let's do. And cd there. su Kelly clear. cd dex. Or no, cd slash home slash copy dex. Oh, I can't even go there. Okay, I'll just do sudo, I guess, like a loser. I can't even do that because it's dumb. Okay, cd sudo ch mod 1777. That's not the, I don't want to turn that on. 777 says home says copy from desktop. Okay, now I should be able to cd. Yeah, okay. How do I make it so any file inherits? How do I make it so any file inherits with perms? I think use a sgid bit. Yeah, sgid bit. G plus S inherits others perms. What about the suid bit? Runs as the owner of the file. Okay, that doesn't matter, I guess. I'll just, I don't think it matters. I'll just go to, I'll just stay here. And then I'll go to my desktop and I'll do, I hope this doesn't crash. SSH, and then I have to do the copy underscore from underscore desktop local host 2222. That's P2222. No such host is known. I forgot how to do it. SSH how to join. User at IP and then the port. SSHP and then user ID. User at. Okay, it's not that. Okay. Copy from desktop. Should work. Cali. Yeah, it worked. Okay, ls cd files clear, and I'll just make a new vim. I'll call it day_1. Vim day_1, and then I'll paste. Instead of doing that, QA, I think I should just like paste stuff into here. Nano, what about nano? Does nano work? Day_1. Okay, nano works. Okay, all I have to do now is just get to my thing. I'm on my home computer right now, and I just have to go to Chrome, and I have to go to Dex. I have to go to Docs. Gotta go to an AI. I'll just use Gemini for now. And then sign in. Okay. Alright, so it should have my thing still on there. Yep, it does. Okay. It has all of my stuff. Okay. Alright, so I already have done this before. Let's see. Okay, so I basically have 4 different drills that I have to do, and yeah. Wow, I hate the fact that ChatGPT is like so slow. That's why I use Gemini. Okay, now time to go and paste it into my thing. Well, I'm pretty sure I have more stuff, so why did I only paste this much? I don't know. I have no idea. Maybe I do. Maybe I'm lying. Yeah, I lied because the thing is, I did paste more stuff. I just like didn't look, so now I have to paste again. Control X. No, day 1. Paste. Now I can Control X, save the buffer. Day 1 dot ASM, I guess. It doesn't really matter. Okay. And then clear, and then quit. SSH, quit. I'll just do D. Control D. Like a loser. So now I should have CD files. If I go here, ls. Yep, I do have day1.asm. Now I can just do Okay, let me see how that sounds on stream. Cause my phone just died and I don't have any other mic. It's probably gonna sound like ass. Okay, is it working? Is it not working? Is it like really low? Like what's going on? Um, yeah, it is. It is very low. Let me boost it a bit more. Filters, gain should be more. Okay, how about now? Is it working? Alright, it seems to be working. It seems to be working. It might be like a bit too loud, but I just apologize to anyone that might be watching in the future. Okay, um, that's fine for now. Alright, let's make a folder. We're gonna call it uh 290-day assembly drills because this is what I framed it as. Like, it's basically supposed to go on for 290 days. There's 4 different drills for each day. Yada yada yada. Yeah. Cancel because we're gonna move this here. Create folder called day one. It's a bit awkward to create folders for every single day, but it's fine. Desktop slash, let's see, 290-day assembly drills. So that's day one. Yep. Cannot move there. Are we serious? How we serious? I can just see sudo. That's easy. Easy money. Okay, let's do this. Now we have to open a terminal here. We have to do this. We have to vim into a C folder, the underscore one dot C. This is what we have to do. We have to look at the file in mousepad. It doesn't matter. This is a drill for every day, right? So we have to look at it. We have to see what is it? D1 underscore one. Okay, so let's. Does it make any function? Does it return anything? Yep, it does. But it doesn't matter at first. We can just like not have any return type. Let's call it void for now. D1 underscore one. We're not sure if it takes any arguments yet. And I hate the fact that when like going in it auto indents. I really don't like that. Instead of doing that, let's just like, how do you make the auto indent length lower? Make auto indent length lower. Vim. Normal mode set shift width. Okay, let's escape real quick. That'd be cute. Let's vim into this thing. Tab stop is equal to 4. shift width, set shift width, put it 2. Honestly, I feel like we should set this to 2 as well. 4 seems like a bit too much. Yeah, I want to get used to like smaller amounts. Isn't that? If we press enter now, should we? Yep, that's good. But like, it's not really like. Honestly, I don't think there should be any auto indent. Yeah, let's just make this a 0. 0 WQ, and I actually do like the smaller thing. Yeah, that's better. So what do we call it? Wait, this is 2, right? This is 4. Dude, for some reason, like, why why does it have to be 3? I didn't want to make it 3 because 3 is an uneven number, but for some reason they have to make it a 3. This is really dumb. Okay, wait, so it's still auto indenting. That's fine. Okay, that's actually perfect. Yeah, that's what I mean. I don't want to make it a 3, but it has to be 3. Soft tab. Okay, escape real quick. More C. Okay. Let's see what's the problem on here. Well, I don't know what this returns, right? And this is a stack frame setup. I have to be able to recognize that pretty quickly. And okay, so this is a stack frame setup. Let's see. Well, we can clearly see that it's moving something into EAX. And right here we can see it's a number. Like I want to pretend that this is hard, but this seems pretty easy. That's why. I'll make a variable, I guess, called. So first, set up the stack. This is how it sets up. So moves RBP. Is there like a drawing? Draw, drawing, drawing, drawing to Cali. Drawing, just drawing to for note taking drawing. External diagramming or note. Handwritten notes. Oh, okay. I mean, I can't really use this because I already have Obsidian. I don't want to. I just need like something to draw, like hand drawing to for Linux. Drawing. This is MS Paint. Drawing Linux. Source code. Do I have to really build this from source? I don't know how to build stuff from source. Dude, nothing else. Source. What's it use? Python. How do you build from Python? Do you build Python stuff? Does it tell you? You can install it from FlatHub. Oh, maybe does Flatpak like have it? Then run it in your file manager. Okay. That dot slash stage mod flat pack. Oh wow, I really need this, bro. I installed it like a couple of days ago. Or not, it was like it was day 9 or something, and bro, I need this again. That's dumb. I have it. How do you flush? Never mind. Guess I'll just open it again. How is it not finding Flatpak? You know what? Instead of this, Flatpak, Flatpak drawing. That says help. Install, run, PS, documents, permissions, install, install, drawing is by the same dude, Mao Sinj. Mao Sinj. Yep, it is. Okay. Cali, this one. Yes, yes. I trust this random ass author, and his name sounds like kind of like Chinese. Hope he isn't a hacker. Mao Sanj. I really hope this is it, bro. But it's a simple tool for drawing. Like, yeah, source code. It should be this dude, right? Okay. As I do that, let me just do this, because I feel like drawing actually helps me understand stuff. So drawing. If I do drawing, bro, are you serious that it was there all along? Where's it from? Drawing. Are we serious? It just is better than flat. Control C. Flat pack drawing. Run. How do you run an application? Run. Run an application. Alright, you know what? I'm uninstalling that. Flat pack. Uninstall. Uninstall. Yes. Yes. Okay. Now I can just do drawing on my terminal. Wow, I should have done that way quicker. Drawing. Really? I have to do that? If I close this. Wait, where's like where's drawing? Where is drawing? It's a good question, right? Where is drawing? It's over there, so that now we can do this. We can make a symbolic link. Do this, right? Ln dash s slash user slash bin. Use. I think I have to do the share. I'll just do bin slash drawing. I'll do share, bro. I don't want to do anything. And then make a symbolic link as home. No, desktop slash, what do I call it? Just call it drawing. Yay. What the? That's not it. Oh yeah, because it's not the same thing. Okay. How do I remove? I just delete. User slash bin. Okay. If I do it again, what happens? This replaces it. Okay. All right, guys. We have drawing app on our computer. How do I make background like black? File. These are settings. View, colors, tools, help, options. Wait, what was the share slash drawing? Where is drawing? Vim slash user slash share slash drawing. You because I know I spelled it wrong. Okay. Share slash user slash share slash drawing slash drawing gray source. This is really stupid. Drawing. Help. Shortcut. Individual pages. Cancel options. Tools. Colors. File. Edit. Edit. It should be. Oh yeah, preferences. Default color. Black. Select. Images tool. Window background color. Okay. Like what? Discard. Drawing. Okay. Okay. This is perfect. This is actually perfect. Can't draw there. That's fine. That's all the space I really need. Okay. So here we can see that. We can see that. Hold on, I gotta take a big fat piss. Okay, my mic is on again. Took a piss. Oh, might not have washed my hands. I'm just joking. Um. Okay. Control Z. Okay. What is this? Okay. You're back. Let's think about this. Let's think about what happens in the stack. Right? When I push, right? Let's say the stack currently looks like this. This is the stack. Terrible drawing, but it's fine. These are the different variables right now in the stack. Now let's say I call D1 underscore one, and then let's say uh this is the currently this will be the BP. Or no, this would be the BP. BP. This would be the SP. right? Bad drawing, but that's what it is. And then, well, since this is BP, this is SP, right? And then it pushes BP to the SP. So now this contains BP, right? Sorry, yeah, no, no, that's good. And BP, right? And this dot dot dot, this goes towards 0x0, right? And above that, this goes towards f, right? 0x ff. And basically, this now stores the value of BP. And let's see what this is. This moves into BP the value of RSP. So now uh, BP will contain the value of RSP, so that now BP is actually pointing here, which used to point to the BP, old BP. And this BP is actually pointing here now. So this is what it looks like. And now when I push something into the stack, so now this is where the BP points. BP is pointing to his old self, but we don't worry about that, right? And then you can see at the end it actually so this would be where it would start at before the function call. This will store the IP, the instruction pointer of the next instruction after the function, and it was stored here, right? And then now after it pushed the BP right here. And now every time you make a variable, so for example, BP is here now, right? And now it's basically gonna just reference these objects now inside, right? Is that how it works? This BP is pointing to the stack right now. Yeah, so BP would so these would be like the older values, right? Or no, yeah, this would be the like this is the way that stack grows. And if I subtract BP like -4, then is going to basically move 3 here. Because BP is also pointing to where SP is right now. So just that. And it's basically never using RSP. It's never pushing the values. That's also like you have to like watch out for that, because if you're programming in assembly, then you have to make sure that you're pushing it if you want to use RSP. Or you can just yeah, but yeah, you have to basically like yeah, you have to make sure that SP is actually like over here, like somewhere else, because BP should be just pointing at the base of this. And then after it does that, uh it just like moves so like in other stuff it might like move into RSP, the value of RBP, so that now SP after changing it would point back to BP, point back to this value, that same value that BP is pointing to. And then after it pops that into BP, then BP will become this again, right? Because this one is pointing to this, and this would basically be set to this. So then it would the ret would again pop this value now, since BP has been popped. Now it points to this value. Okay. So that makes me that helps me understand a bit better too, even though now the drawing looks like ass. Okay, so let's do this. So what's it doing right now? Basically just doing what I just said. So it's going to remove that because that's not how it works. Um, push RBP, move RBP to RSP. The stack frame setup, we can just ignore this from now on, since we know the concept now. Int Well, it's moving like a double word into here, right? It's not moving like a Q word, which would be a 64-bit value, but it's moving a double word, so it's a integer. It's not like a long. Uh, and then it moves into it int rbp underscore 4 equals 3. And this is the style I'm gonna be using. I'll just be saying rbp underscore 4 for rbp minus 4, and then int rbp underscore a is moving equals 7. And now eax is being set to whatever is contained inside of rbp minus 4, whatever it points to. It points to 3. So eax right now is equal to 3, because it directly sets to that, and then just return. So in other words, just return rbp minus 4. Return rbp minus 4. rbp underscore 4, sorry. And so we know now the return value is int. So that's how we determine the return value. And we do the same thing with the next one, d1 underscore 2. And then it pushes rbp, same stack setup again. And then again, rbp minus 4 is equal to 5. So let's do that. Int rbp minus 4 equals 5. Int rbp minus 8 equals 10. And then it moves eax is equal to rbp minus 4. And then it adds to eax. So instead of doing that, I can just like set rbp minus 12 to eax. Okay, let's do that. Int rbp minus 12 will be equal to this value. Just eax is being set to 5 plus 10, and that's 15. So rbp underscore 4 plus rbp underscore 8. And then what does it do? It it moves into it back, which is kind of redundant because eax already contains that. So, and then it returns rbp underscore 12. Okay, that's simple enough. And we know again it's an integer because we can see again it's moving a d word. I think all of these are going to be moving a d word. I don't think we need to worry too much about that. The point is just to get like the hang of it. And these are just basically the warm-ups, right? And we're gonna have I'm planning to download like crack mutes to actually do the drills. And crack me is kind of sus, but yeah. Okay, sorry. Int d1 underscore 3, or not int because we don't know yet. d1 underscore 3. Let's see, and do that, and do that, and do that. And we could do again, same stack setup, moves 20 into it, int 4 equals 20, int underscore 8 equals 4, and then int, and what's it do? What's it doing? It's moving into eax, d word pointer rbp underscore 4, and then it's subtracting from that rbp minus 8. Okay, so and then what's it do? It sets it to rbp underscore 12. It's 20 minus, not that, rbp minus underscore 4 minus rbp underscore 8, and then just return this again, underscore 12, so that now we can, so we just like return return that again, and then set that to int. Oops, sorry. And then int d1 underscore 4. Let's see, what's it doing? Void d1 underscore 4. What's it doing? Let's see. Oh, same stack setup. Move into 4. Oops, sorry. Int rbp underscore 4 equals 6. Int rbp underscore 8 equals 3. Int rbp underscore 12 equals 2. Move into eax rbp underscore 4, and then add rbp plus 8. So we can, let's just do this. Have what's it doing? Moving 6 into moving rbp underscore 4 and then adding 8 to it. So underscore 4 plus 8, because we already know that it's gonna be something like this. And then moving into rbp underscore 16. So int rbp underscore 16, since we don't have that variable. And then moves into eax that, and then adds rbp into, adds 12 into that. So rbp underscore 16 plus 12, rbp underscore 12. And what's to do with it? What's to do it? It sets that into rbp underscore 20. Okay, rbp underscore, that's a whole lot of addition, but okay. And then moves into eax rbp underscore 20, and then pop, and then return. Okay, return rbp underscore 20 int. This is basically just adding all three of these and then setting it to, just adding these three together. Okay, that's whatever, I guess. Well, yeah, that's basically it for day one's drill. And I don't think I should be doing, these are supposed to be warm-ups, right? I don't, like, I'm not supposed to be doing like too much of these. Let's open it. Yep, looks correct. Now we can just like be done with this. Now the next thing we do every single day, and I don't think we need to log this in, like Obsidian. I guess it's kind of necessary to log it, because then I can retain it better. So what did I do? I learned a bit about stack frame stuff. RBP is pushed. This is job. Now we can download like a crack me. Hey yo. Hey, let's download like a reverse engineering tool for Linux. I'm not sure whether people use IDA or something else. Ghidra, okay. I know Ghidra is like good because it just is, right? Yeah, GDB is a debugger. Um, Ghidra, and I need to get like Ltrace and S-Tray too. But yeah, let's just start with Ghidra. Not sure how to install this. What does this contain? Ghidra Linux. Cancel it. Retry. Cancel it. Because I want to do this. I want to, oh, you can just, is it like a downloadable thing? Sudo apt install Ghidra. Okay. Wait, is it already Ghidra? Ghidra. Ghidra. It should take like a long install, right? Yeah. Honestly, not really. Kind of a long install. Okay, now let's find crack music. Should we make an account? Maybe, possibly. We should register. Takes an email as well. Uh, you know what? I don't really want to show like my email on stream. Let me just like um yeah. I'm just gonna like hide my screen for a bit. Okay, guys. I'm back. So 0xFAFO wasn't seem to be like disconnected. So I'm really happy about that. 'Cause that's actually my YouTube thing. Yeah. CTF is a thing. Oh, that's cool. What is this dude? He seems really crazy. Top 100. Which, like, let me choose my favorite. I like this dude. Like, bro, like, he's insane. Who is this? What a cool dude. Okay. Anyways, I'll stop glazing. Challenges. Matter of time. Let's see. These look hard. Read me. Some things only make sense at the right moment. Okay. You know what? We're not doing that. Latest crack news. Surge actually. Crack me doesn't matter. Difficulty between 1 and 2. Right? And quality between higher than 4. Downloads between doesn't matter. But I'll just try to get like a C/C++, this Linux. Okay, did I select it? Quality downloads. Instead of doing that, I'll just put like 1.6. Descending or ascending. Downloads definitely, right? And then search. Okay. Difficulty is a 1. Simple crack me. That's a lot of downloads. Let's download like how do you get how to what is the what is it called, like what is the flow chart for crack reverse? You run like strings on it, or this is what I want to do. Developed to crack me on Microsoft. Observe for any interesting strings. I won't do that. I just want to do static analysis. can use it after the three instruction in 32-bit. But how do you find it in 64-bit? Well, I guess since I know that it's usually LEA or something. I don't know. But I do know that first register is RDI, second is RSI, third is RDX, fourth is RCX, um, fifth is R8, sixth is R9, and that's all I really need to crack anything. I'm gonna crack. Okay, anyway, I'll stop. Let's go. Idra. I also make like a shortcut to it at my thing. Where is Ayo? Where is Idra? Okay. Now, what do you call it? I make a shortcut ln dash s slash user slash bin slash ghid gidra slash at slash desktop. Okay, now we should have a symbolic link to Gidra. We do. Close. So, what do we have open? Downloaded Gidra. Wow, day 11 is really like productive. Learn 290 days. What is learn? Oh. Oh yeah, we need to finish this, right? Also, the tab needs to be reduced. Because that's, how much is that? Wait, that's actually the correct size. I don't understand why there's two. That's stupid. I'm not really sure what I'm trying to do with that. Also, I don't need this. Because it already kind of has a cache. If I'm just like, yeah, okay. I think I was here earlier. Yeah, I'll do this later. I don't wanna like get carried away. I have to carry. I can't be carried. Obsidian. Run and identify. I mean, running is a good way, but it's just like I just want to do strings. File to determine what type it is. Strings. There's a strings command, right? Strings. Strings on slash bin slash what's it called? Ghidra. These are all of the strings in Ghidra. Can you specify like what type of length you have? Maximum heap is might be changed. All just in files. Options are all. Oh, you can do that. Only scan the data section in the file. And the data section is default as well. Print file name for a string. Number, locate and print any sequence. That's just bytes. Print it of at least number characters. T. Oh yeah, this seems cool. In base 10, octa, deca, hexadecimal, dash t, dash radix equals x, um, dash o, and yes for radix equals 0, or radix equals octa. Okay, cool. Um, okay, so let's download this. Like just as a startup, right? Show all downloads. Remove from history. Remove from history. Can I just remove all of them from history? Okay. And I'm pretty sure I have to like I can do that, but I have to do crack me's dot one. That's it. Okay. Paste that here. What the why do I have to do this again? Kelly. Oh, I have to put my own password? No, that's not it. Yeah, that's the wrong password. And it's already here, right? Delete. Delete. Okay. Trash again. Extract. Oh, okay, that's how I do it. Do I just press enter? Enter? Wrong password. Okay, I have to input the correct password. Oh, I can't even click there. Your name, open with. How do I put the password? Bro, how to extract zip Kali. I like the fact that Kali is like similar to desktop. Unzip SP password. Okay. So do I just like extract? Oh, I can do that. Oh, okay. What is the passwords again? Passwords for crack me's. Crack me's crackme's dot one. Crackme's dot one. CRACKMES dot ONE. Yay, okay. Now, okay, we have the C++ file in here. Okay, now we can put, wait, we should do this. We should open this on here too. Right, compile this, I guess. And extract, I guess. Trash. Open terminal. Cat read me.md. Cat read me.md. It's a simple, crackable written C++ compiled with GNU. Oh, so this is already compiled. Okay. And stored in plain text does not contain. Okay, bro. It's like, are you serious? Do I just have to do strings on C++ crack me? Like, well, um, I'm assuming it's gonna ask me for a password. Uh, Right password. Enter the password. We already have it here. Change the string if you can. I'm not gonna change that. You think I'm an idiot? Enter the password. Is this the password? Like, oh, okay. I guess I'm assuming this is the password. Hidden in plain sight. This is hidden in plain sight. Unless it's this random shit. Like, this seems weird that this would just like show up. I think this is the password. I don't think this is the password. I think this is the password. Because there's no other like random shit that just like shows up. That's like too many. That's like too, like this is too rare to just show up on its own. And with especially with that amount of length, I can think of this showing up, but not this. Okay, so let's just do. Where's it at? Right here. Well, I just like this copy section, echo, paste. Oh well, I could do that, I guess. Right? Doesn't matter. Yeah, I don't know what that is. Paste section, enter, and what is it again? Just as correct. Change the string if you can. Paste. Oh yeah, I should have guessed this would be the enter, not the password. Okay, we did it, guys. We cracked it. And if I just to prove it, if I enter anything else, yep, we cracked it. Let's try to open this in Ghidra to see, because that's what I wanted to do originally. Slash C plus plus me. Is that how I select the file? Yes. This specified file is not a project file. Goes file, new project, I guess, non-shared project. Mm, Here, crack, static. Like, what is that doing, bro? File, open, history, hide history, cancel. I guess I should like make a Ghidra for um project. Close delete project. File, new project, non-shared project. It should be called um in here day one. File name should be Control Z. Day one, right? And I should call it static. Yeah. That's because I did open project. Next. Static. Finish, right? And now, file, delete project. This one, delete, delete. Now I can open code browser, and now I can open a file, static. No, cancel. Bro, like, is there no way to just like open up? Does it really have to be this hard? Like, come on, bro. Um, file, file, delete project. Day one, PPR, delete file. Like, is there no way? Can I not like drag and drop into here? Dude, does it have to be this hard? How to use Ghidra Linux. Can't believe I'm doing this. Ghidra introduction, Linux install project, new project, non-shared file, import file, select a file. Okay. New project directory. Okay, I guess I'll just like Ghidra projects. Where did it go? Projects. Did I hit cancel instead of create? Where did it go? Where did Ghidra just disappear to? Empty trash. Wait, but where did Ghidra go? Yeah, seriously. Huh? This is not Ghidra. This is not Ghidra. Not Ghidra. Inside here. Did I just like delete the same link? Okay, bro. I might have just deleted the same link. Where is Ghidra? And then that. Okay, I have it again. If I do it again, nothing changes. Is it because I like did that? That's really dumb. That's kind of dangerous. Okay, let's put it here then. Let's like make a separate section. Let's organize the files in my desktop. Obsidian should be here. Drawing should be here. Future should be here. Put it, actually no, put it here. Put it here. And then this should be here. This should actually be here. This is important. This is actually important, and this is important. This is important too. No, put it where somewhere like obvious, like somewhere that just like stands out, like right here. Right here is good. Close. Okay. New project. Next. Desktop. Ghidra projects. Select project directory. Project name. Day one underscore static analysis. Finish. Wow. Emulator. Like, am I supposed to do a file import? File desktop day one. Select file to imports. Ooh. That's how I'm supposed to do it. What is this though? Oh, I can like put folders inside of it. Import. Okay. It already detected it. Okay. And did it say compatible with GCC? Okay. What's this mean? Okay. Now what can I do? Okay. Double click. Yes. Amazing. If I don't analyze it, what does that mean? Like I can analyze it, right? But what is that? Analyze. That was quick. Already finished. Okay, guys. So let's see. Where's main? Main? Oh wow. Unassigned. Okay. Wait, is this main? Like how? Like where's this? Libc start main. Okay. And we can see. Right. Let's see. Let's see. Let's try to like see what's happening. Push RAX. Pushes RAX. Does it ever pop RAX? No. It just calls this function. Libc start main. Okay. Thunk. Start. Libc start main. Address is this. This is undefined. Okay. Okay, it's loading here the main. We know that RDI is the first param and RSI is the second param. So it pops into RSI. It pops something into it. Let's see what's in the second param. Third is RDX. Pops the current stack in there. Okay, so like meaning we know that if we add stuff to the RSP, then it ends it with minus, what is this value? Yeah, this is minus 10. What happens? Oh, this is aligning it. Oh, okay. So this is aligning that stack. Okay. How is it aligning it? It's aligning it to be mod 16. That's what it's doing. But I've never really understood why must you align? Why must you align stack to 16 bytes? Managed by this SMID. Many SSE operate require memory address if in a line. Move APS is on a may trigger this. Why does SSE? Let's study this. I'll just comment like a comment done, because now I can see where I commented. Can I see my comments? One. What else can I see on my profile? Number of crack me's. Can I post like write-ups? Submit a write-up. Okay. Guess I'll make a write-up. Infos. I guess I'll just do infos. Use strings to find the odd looking. Do I have it here? Odd looking characters which shouldn't naturally occur. Mixes stuff like that's what it does. Basically that. And it's like too long to be like okay, did I make a write up? Okay, it didn't work probably because I need a file. Okay. Whatever, right? It doesn't matter. I guess my stream is my write up, right? Yeah, it's a bit cheesy, but it is. That's the password. Um. Okay. Wait. So let's study why does it need to be? Why does it need alignment to optimize data access? Okay. To be loaded into registers in a single can cause segmentation faults. So boundaries, just like 16-byte boundaries. Oh, okay. I understand. Oh, okay. Yeah, that's why I understand. So, okay, because it puts the data into the cache, right? Whatever the chunks you touch, it puts that into a cache. But if it's not in the 16-byte range, then it accesses like a bit more. So if it was like 9, like aligned with like 9, then um 9 times 2 is like 18. That would access like 2 more bytes into the second chunk, and that might not be like protected and stuff. And yeah, and when you try to do this with that, then like it might cause a fault. Okay, kind of makes sense, I guess. Okay, I know. I probably need to learn more, and I will try to learn more today. For that. Like, what is this code browser? Oh yeah, here's what we need. Start xref is here. Right, entry point. This is where start is called. No, this defines the entry. This one also defines the entry. What is this? Frame descriptor. Frame description. What is a frame description? What is all of that? I don't understand any of this, bro. Local 10. Would just start. What? What the fuck? Wait, RSP is local 10. Let's see what's happening. So first let's see, RSP is ANDed first, but it uses similar RSP to yours, so it doesn't care that much about the fact that main might like do some random shit with the stack, right? It doesn't really care about the variables much. And then it pushes RX and then pushes this value, pushes R8. It doesn't push it, but XOR and XOR ECX. So LDI main, right? Okay. And so the next one will be RSI. It's popping something into RSI. I don't know what is being popped into RSI though. What is this? This this. Wow, I really don't know. I mean, okay, I guess I'll just look here. Okay, let's see what it's doing. Oh, and this is also a good way to learn. We can just like make the C function right here. Um, 290 days, day one. Track me underscore no letters. Okay, terminal here. Okay, let's see what it's doing. Then crack me underscore crack me dash no letters. Let's see. Okay, insert. Okay, so it sets up stack stuff, pushes RBX, and we know that it's good because so now we know that it's gonna be using RBX because we know that things like RBX is a colleague saved register. Subs RSP to 0x68 bytes. Okay, and then they um FS, bro. Are we serious? Exception handling. Okay, wait, what is 0x28? What's FS 28? Stack canary. Oh, okay. This is to protect the guard, and we know that if this gets overwritten, then it's gonna be bad. And then it's gonna store local 20. Oh, okay. Local 20. Can we not do this, bro? Local 20 is just like offset 20. Yeah, that's really stupid. I hate the fact that instead of doing that, it should do like minus, right? So we know that int main, it takes in a, well, let's include stuff. CDIO. We know it's int main. It takes in a RC arg b, right? And then and yeah, let's see what it's doing. So it's moving int um rbp underscore 20 equals, well, first we can make a comment saying, wow, comment is really dark on here. Damn, like it's like invisible for me. Okay, let me lower my like night light. That's why I have like invisible comments. Lower that. Okay. Now, wow, that's like kind of too bright for me. Okay, that's still too bright. almost good. Light. Okay, that's actually good enough. Okay, that's good. That's good. Okay, now we can do this. Let's see. It moves the stack. Okay, well we can like let's write down notes. Okay, in Obsidian we can write down notes. Typically, Fest 28 contains stack and let's see how does it deal with that? I know it uses something like XOR or something. Where is ret call check fill. Where is return, bro? Here. Okay. Call stack check fill. So what does it do? Like what, bro? How do I go back here? JG here. Oh, okay. Here's the operation. Okay. Move into RBX, right? And move into RDX plus minus 18 plus minus 18, meaning just go 18. Um, is local 20 hex 20 or is it? Yeah, it is hex 20. Okay. 0x 28. I'm thinking um well it moves into RDX the value at RBP underscore 18. And then it subtracts into RDX. It subtracts from RDX that value. Where else does it check for stack? Stack check fill. Okay, it does it here as well. This subtracts from RDX's value. And if it's 0, then if then oh, okay. So this and this are the same value, okay? Local 18 should also be that. Local 18. Let's see where does that local 18 get assigned? Local 18. Local 18. There's no local 18, right? But there's the stuff. How does it like Jay-Z Zump? I mean, it must have done this for some reason, right? Jump to there. It just does stack check fail. Bro, like why? I don't understand. Cause it's actively using local 20. Oh yeah, because it's also supposed to be the same, bro. Okay, I'm dumb. I'm dumb. Let's see. Like, where does this get set? IBP plus IBP minus 18. Where does that ever get set? Okay, whatever. I guess we'll just figure that out as we go. Let's open this then. Okay. It allocates how much? Allocates it let's say it subtracts. Is there no way I can make comments white? How to make comments gray slash white and yeah, read on board. I did it on background. Okay. Paste. Dumb just happened. F fifth 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 fifth. That should have been good. Insert. Still not good. Well, set background equals dark. Maybe that's it. Set background equals dark. Right or no? Set background equals dark. That is how it's supposed to be. Now if I do insert, make a comment, still makes it that color. Paste. Um, comment. Okay, that's a bit more visible. Is there like a where does light blue come from? High comment equals light yellow. Is that a thing? Oh, it is. That's way better. Vim Vim size. Insert light yellow WQ. Oh, okay, so now we can do that. Let's go. Let's go. Let's go. Currently 2:41 a.m. So you can see, comment. Okay. Okay. Wait. Where am I? Did I crash? No. Okay. So what's happening? Let's see. What happens in here? Observes. Okay, so it does this subs 668 from RSP, and then RBP 20 equals what do I call it? FS 20 equals stack canary standard IO dot H. Oops. This is what it does, right? Canary, then get its XORs 0.eax loads into EAX, this value loads into EAX. I don't understand that. Loads into loads into RDX. Hmm. What, like, I don't understand Ghidra syntax. Syntax. Return the idea LEA. How do I change, like, what type of syntax Ghidra outputs? Because I don't, like, what does this mean? Like, Ghidra syntax. Ugh. Like, what does this mean? Mm. Oh, okay. So loading the address of this resolves to this. Okay. So LEA is, I mean, RX is pointing to local underscore 71. But how is this already decided? How is minus 69? Mm. I mean, this is like one, like 68 to 69. That's just one byte. Um, yeah, and this is many bytes. It's like 48, and it has to get to like, what is it? It has to add how much to get to 15? Um, how much to get to 50 first? It has to add eight bytes to get to 50, and then 8 bytes again. No. It has to add 8 bytes to get to 50, and then it has to add 16. Yeah, it has to add 16 bytes to get to 60, hex 60, and then hex 60 has to add 8 more bytes to get to minus 68. So 16 plus 6 is 24, plus 8 is um oh sorry, 16 plus 6 is 22, plus 8 is 30. So there's a 30 byte gap between minus 0x48 and minus 0x68. Oh, okay. So, oh, this is 16 byte. Um, local local 10 is 16 byte. Local 20 is, the thing extends up to, what is it? 20 to 40 is 20 to 30 is 16. Yeah, this is a quad word, so this is 64 bytes. Okay, so 20 to 30 is 10 bytes, right? And then 20 to 20 to this might be an array. 20 to like 20 to 30 is 15 bytes of difference, or you can say 16 bytes. And then 30 to 40 is 16 bytes again, so that's 32 bytes right there. I don't understand the mechanics of this, the insane mechanics. 0x48 minus 0x20 x28. Oh, can you just do subtraction like that? Doesn't 40 bytes of difference. Yeah, that's what I'm thinking too, because 20 to 30 is 16 bytes, and then plus 16 would be 32 bytes, plus 8 would be 40 bytes. But that doesn't, like, how does that make it a quad word? Oh, that's because quad word is 8 bytes, bro. Oh my. I'm really stupid. Okay. Yeah, quad words are 8 bytes. I think it's just like displacing the variables far just because it wants to. And these variables are stupid because, well, it only reserves space for 68 hex 68 bytes. Oh, okay. Oh wait, what would be hex 68 divided by 8? 0x 68 divided by 8. 0x d. And d is what? 68 divided, because 68 is not divisible by 8. It's 8.5 times 2 is 16. Wow, I wonder like how to learn, like how do you learn how to do hexadecimal stuff? Let's do this practice. How do you like make it so that automatically like your number base in your mind is this base 16? I got any of this Hey, I always wondered why don't computers use base 8 instead of base 16? X maps more efficiently. Mm, okay. Represents neatly 4 bits and 1 byte is 2 hex. Okay, why not? Why not 4 then? Hex. Not use base 4. It offers superior data density. I guess so. And then like the next one will be 16 times 16. Yeah, like 16 seems to be like the perfect number for computers. Because 4 is too small, right? And then the next power is this um the next power is 256 because 2 times 2 is 4, right? And 4 times 4 is 16. 16 times 16 is 256. We don't have that much resources because that would take 16 times more resources and probably even more like nuances to set the stuff up. Okay, anyways, RAX, where are we at? Okay, yeah, we're just at the stack cannery. Um, moves this byte, which is offset of. Oh, and I forget one thing is that it goes from minus 69 to like above, meaning it goes to minus 68, minus 67. Okay. I need to keep that in mind because this would actually decrease upwards. Oh, so then this being eight bytes also makes sense because 10 to 20 is 16 and there's like 8 byte of gap still, but yeah, it makes a bit more sense. And this being 10, there's 8 8 more. Okay, because probably yeah, this is the return address at the ESP. I think that's what this return means, right? So See what there is. Secondary, and then loads into array x RBP RBP plus minus 69. So this int RBP underscore 69 equals, well, it moves into 70. Oh, is that what this means? It's about to move it into, that's not what that means. Yeah, that's not what that means. Okay. Like, that's like a really weird number. But I guess we might be able to find out why. As we do this, I'm really tired. It's almost 3 a.m. Let's see. It moves, oh, no, sorry. Int RBP underscore 60. Oh, it stores the address 69. Okay. Underscore 71 equals the address of RBP underscore 69. Okay. And we'll just define define int RBP underscore 69 here. Okay, and then what's it do with that? Um, there's two knob instructions, probably to align it or something, shit like that. There's so many like nuances that I'm probably ignoring, like how there's like 71, 70, why there is that, and like nuances like knob instructions here. Probably even like the sizes of these operations. I guess I'll know them in the future. I do this more, and learn more. Okay. Okay, so RBP underscore 71. No, wait, actually, wait. No. It stores it into local 70. Okay. And for some reason, 0x69, it seems to be pointing at this or something like that. And then it loads into, so this is a string, I guess. It loads into RCX plus this. The string plus this. String underscore. Oh, okay. This is the string and this is the where the address is. Okay. So this is um char underscore addr underscore 00103008 equals the string. Copy paste. Copy. Okay. And then paste here. Right. And then and then it loads into RCX the address of that, and it loads into RX local 68, or no, it loads into it RBP plus um minus 0x60, which seems to point to local underscore 68. Okay. The names are so confusing. Like, why is your local 71 right here? Alright, well, I guess I can. Let's just Google it instead of like ignoring, so that we can see. In Ghidra, Gemini. Gemini is my lifesaver. This is Ghidra's analyzed. Identify is a local variable. Mm. Oh, okay. Okay. That makes sense. Okay. It's just like a alias. But yeah, okay. So this is like then it's confusing because it didn't name it local 69. It named it this. Yeah, it's kind of whack. Whatever. Yeah, that's why I'm not gonna rely on these. I'm just gonna rely on these stuff. Um, and what's it do after that? Um, it loads into RCX this result, right? So I can let me just call it data underscore that, and then I guess not just like a string, right? 'Cause we don't know if we don't know what it is, right? It's just the data loading into that, and then it's because we're just defining that this data exists right here. And that's what when I compile this, if I make it a const, then that's what same thing is gonna do the same exact same thing. It's gonna save this as a. It's not gonna have this address. This is our name for it. But yeah, because we're naming it in terms of this, right? We're trying to figure out what this does. That's why we're using the same name here. But when we compile our own code, it's gonna change all of these because this isn't actually RBP underscore 20. This is just some variable that I created. And stack canary doesn't even exist, so it's not even gonna compile. So that was a lot. That was a lot to say. That was a mouthful. Hey yo. Okay, anyways, sorry. Um, make sure that no one is watching the stream because I don't want to be embarrassed like that. Okay. No one watching. That's good. And we've been going for 2 hours 33 minutes. That's good. And even though on stream we didn't make as much progress, it's fine because out of stream we did make some progress. Let's see. And tomorrow in the morning I'm gonna go to gym so that I can stream again right after coming from the gym. Okay. Yes. Thank you. Okay. So what are we doing? RBP plus local 70. Yeah, we already did that. We already named that. But like, bro, um, Yeah, whatever. I'll ignore it for now. And loads into a RBP plus minus 0x60. It didn't even like save it, bro. Well, we know that this is the uh, third param, second param, not a param, and it's not calling like a function or anything. So I think we're good. Um, well, it is actually calling a function right here. So it's calling this function string. Okay. It's calling this thing. It's something related to string. Yeah, I'll stop. I'll stop trying to be mysterious. I'll just open it. I know this is like probably the string function. Param1 allocator. Yeah, this is definitely like like making the string. Go back to main. Um. Okay, so let's see what we're doing. It first loads into uh RDX is equal to this, right? R RBP underscore 69, right? The address of that RBP score 69, right? And what else? And RCX equals data underscore 00103008. RCX is the address of that, address of that, address of that, address of that. RDX is the address of that, and then it loads into RX local 68, which is this local minus 60. Okay, RAX equals RBP underscore 60. Let's see what it does with this. Wow, I can't. I have no idea what we might do, guys. This is insane. RAX equals that, and RDI, and RSI. It sets it to. It just sets it to the data, which makes no sense. Then why did it load it into RCX? Guess we'll figure that out. Okay. RDI, RSI is equal to data. Oh, it's because it's directly moving. Okay. RCX, and then we can comment that, and it's not loading, it's moving. And this is the move into it just the RCX, so it's still moving the address of it because RCX was loaded with the address of that address of data underscore 001030, because data directly points to this, and we're just loading the address of that address of the thing. So are we loading the pointer, or what are we doing? Because if data, okay, so data is a pointer, right? Data is pointing to this and data is just like an offset from the data table, and then we load the effective address data. So we just load data as it is. So we just load that. Okay, okay, okay. Which is just this. Okay. Yeah, that makes sense. And RAX and everything else seems to be correct. RSI is equal to this RCX, which is this. And then, okay. And then RDI is equal to RAX, which is equal to RBP underscore 60. And this is actually the address of it, so, okay. And now we can actually see what's going on here. Now we can see that it calls a function inside of a try block, by the way. Try. And there's an accept try. Okay, this is just one try block, okay. And inside the one try block, it does this. Is there really no like accept block? And from that, oh, catch is here. Try this, right? From try 102, which is this. Try, okay. How does it prepare like the try and catch though? Catch, right? Try and then the catch this at this. Okay. It doesn't really tell me where it has the catch handler, so just have to do it here. Let's complete the catch block first. But this is this is everything about the catch block. Move into RBX result of RX and move and load into this thing. Um and move into, honestly, I think I need to like do this part before trying to I'll have to like do the try block first. So string, what does it return? It doesn't return anything, okay? Uh, just call it string something, right? And it passes in RDI, which would be RBP underscore 60, right? Address of that. And it passes in it passes in what, like um well it's gonna pass in first is RDI, second is RSI, which would be data underscore 00103030, right? And keep in mind that this won't be only because it's like a standard function, then that's why it has these type of args. It's like, keep in mind that if it's like a hacker or someone making it, then of course they're gonna like mess up the calling conventions. Like they're probably gonna like pass in the stack pointer as a first argument. It was a really like, yeah, like what are you doing? Right? That's what they have to do, because we are the pro defensive teams. Okay, we will defend anyone and we will defend everyone. Okay. Sorry, don't hack me, please don't hack me. Um, that and then just passes that in, which is a pointer. So it just passes in the pointer, and then it passes in. What does it pass in? It goes from RDI, RSI, RDX, and then RCX after that. RDX will be RBP underscore 69. Okay. So is local 70 ever used? So it just passes in address of RBP underscore 69. RCX is just the data again. So this data again. But how many things does this take? String. It doesn't take like anything else. Unless is this like what is the third param again? It passes in RBP under is this the allocator? So is RBP underscore 69 the allocator? It doesn't really seem like the allocator. Like why would that be the allocator, right? And is this just like what is the point of doing this? It literally does like nothing with that address. Oh wait, never mind. It does do something, right? But what is the oh wait, it does save it here. Okay. But like wait, why? Like it doesn't create an allocator or anything. It's creating the allocator on here. It's like it's asking for this pointer on here, right? Is it new allocator? Yeah, it's asking for this pointer on here. Okay, it just calls string. Tries to make it with like a blank allocator. Unless it's like somehow already like a thing. That could be the case though. Like it's already defined. Local 71 is 69. Local 71. Um, I don't understand. I don't understand. I don't understand. Why would it pass in like a blank address for a new allocator? Gemini. Let's see how this function works. Oh wait, maybe we can just like reverse engineer that as well. I don't want to like go into every single. I just want to like reverse one function because otherwise that's gonna take too much time. And besides, like, why would this? What does this do? Um, I mean, there's no way I can even reverse it. So I'm not being lazy, right? Kinda am, but like, okay, let's just ask Gemini. What is for the shrink function in C++? What's it taken as a class, right? Um, can you pass in a custom allocator? Wait. Here is like something to S2. We know that we don't like we know that it's not doing that. a fixed type. Is it type def for this? Okay. As hello and alloc. What is my allocator like in memory? How is it stored? Is it just a bunch of when you define my cater alloc? What's it do in assembly code? Is a placeholder. Okay. What if you put in like like what if you put in an address on the stack that you've defined, such as RBP minus 0x69, and you don't do anything else with that, but you just pass it there, such as string. Um, well, takes in the this pointer, which is it returns it as that, right? Yeah, it returns it as that, and then you have to make the data, so it's string data, const card data, or data, um, and then you pass in uh address of RBP minus 6069. If you tried it directly, they're strictly typed. Whereas expect if you pass, the compiler will stop. However, use that stack space. The this pointer address reloaded into RDX or R8. Or the calling convention is Linux to serve as the this pointer for the allocators method. What? To use as the this pointer to that to serve as the this pointer for the allocators method. Oh, okay. When the string tries to grow, it will call if is this a random site garbage and not a valid with vtable or functional methods. Okay. So then the shit crash. Let me actually try to like debug this in GDB. Cause how is this working, bro? It shouldn't this like unless the catch has something for it. Catch, right? And it doesn't even have anything. It loads it in here. Move knob sub jump 0. This is the stack check. Um can you not expand this? Hey, how do you expand? Like what do you have to do first? Analysis. Analyze. Call. What if I like run it? Can I debug? What? How is this working, bro? Maybe I'm like really stupid. Catch. Why? How is it catch not expanded? How do we expand catches? We know that there's a catch, right? And it catches except E, right? Or something else. It doesn't matter. But like we know that it like catches something. Um, expand catch block. Um, for storage. So what's this code doing? Dude, I'm sorry, I have to resort this because I seriously don't know what's going on. Okay. So from here, copy, paste here, classic being initialized, stack canary, and then store the address. Okay, it's getting some stuff wrong. This is not an actual address. This is right because 68. Yeah, that's not an address. This is this, not 68. So it's 60. Um, call the constructor. Yeah, that's what I mean. What's the like? Oh, okay. Oh, okay. So it's just STD cater char. But what's that really mean? What does that mean for a string? Is a travel agent is usually quite small. That's sure. Oh, the long sequence of character inside it holds a pointer to location that calls whenever it needs to return that memory. It dictates where. By default, it uses operator new. But how does that 1 byte worth of thing tell the string anything? You know, nothing to. It doesn't in C++ is a dummy. It doesn't contain it. Satisfy the type stream. Even if a class has no, the compiler gives it size. Doesn't look in your code. Type of the third argument. Oh, so it's just a dummy that's there for just the sake of the third argument existing. And inside the string function is already optimized to be allocated using correct functions. So where is there a check that checks whether a third object is passed in or not, or what? Why does it even exist inside the string function? Because it's impossible to not to pass it in. Why doesn't the compiler just without okay? Well, but well, if if compiler wants to optimize in a anyway, why does it even need objects? Why in the source? Why in the assembly code after being compiled does it still exist? The $1 million question, why did it leave that trash? We are looking at unoptimized build. Compiler so told. Oh, okay, yeah. I'll load address because it wants to match the source code. So I step through it without getting confused. Okay. When your code was compiled, I didn't know what the string constructor was going to do. It only knew the signature. It couldn't prove that the thing was okay. Okay. And don't need the third argument in assembly. Okay. Then every time it would break because okay, Must put something in the RDX register. Always expect something. I mean, bro, like there's nothing. Yeah, whatever, whatever. Okay, but it's still bothering me. Scaffolding, address of nothing. Can't pass zero because it might try to dereference. It can't pass random because it might belong to another variable. Looks at RDS, valid piece of memory. Precompiled. It has a specific entry point. Yeah, I get it. I get it. It's just to like um do that. Except do stuff. And after that, what's to do? Guys, bro, like this is taking pretty long. Mm, okay. Well, it loads the thing calls new allocator method. That's what I don't understand. Why? If you already made this, right? So why? Why would you do that? Move RDI into RIX, right? And then call this method. And then no op just to align, I guess. And then load into RX this address. And then immediately into RDI move that address. So basically nothing just happened. I'm just joking because well, my bad, sorry. Because uh this actually did make a new allocator. So just earlier here it wasn't like passing, but now it's like doing it's making a thing. Okay. Imports. Wow, C++ is like disgusting to like analyze, bro. Functions, classes. Okay. Um, loads that into there and RSI. What is RSI equal to? RSI is unchanged, right? Because even after calling this, well, no, it might be changed because like RSI can it's a collars saved register, right? What are the collars saved registers again? It is RAX and then RDX, RCX, RDX, and then RDI, RSI, and from R8 to R11. Kali saved is this RBP, RBP, RBX, and from R12 to R15. So yeah, this is a Kali register, right? So I don't understand it. Like why wouldn't they save it? Unless the compiler is like fully aware, and I'm just gonna say that it is. Or that this function, string function doesn't require like anything else. Or I guess I'll just assume that RSI is unchanged and it still contains the data thing. So it moves into RDI again, and then it calls the string function. it calls the string function. It actually it loads um yeah, it loads into RAX this thing, which would be the this pointer. Wait, but yeah, wait, like how? Dude, like I don't understand. Okay, wait, so I don't understand the fact that oh and yeah, like at the start of the stream I was talking about how I'm gonna like make a I'm gonna start make a stream on another channel for like the speaking channel. But yeah, that's not happening today, bro. The stream is going on for 3 hours today. Ugh, and it's not that productive either, bro. Like, yeah, it's fine. I don't understand though. Like, what is happening? I guess this is like necessary torture because like everything is gonna be like this, bro. It makes a new allocator, but right here it doesn't because it doesn't feel that it's necessary to do that. And then it makes another pointer as 0.00x40 or BP plus or BP underscore 40, and it makes a pointer that just it's just the same thing. Like it's just this like doing this over again, but this time it doesn't even do the try thing. Okay, and then it moves into RDX this and then just counts that out, which makes sense. Um, or wait, yeah, wait, moves into RAX this the function count, and it probably calls RAX, right? Oh, it first calls this operator. Oh, okay. I'm starting to understand how this works. I'm assuming that. Okay. So it loads into RDI this RAX, which is this count. RSI is this the message, and and oh yeah, RSI gets set to RDX, right? Because you can't just like yeah, like how do I expand this? Expand, clear, edit, fallout references, instruction info, RDX. Yep, it it moves into this, and that's confusing because I don't know what these numbers are. So instead of that, whereas yeah, so RDX is the input, and result is a side. Okay. So let's write that down in our C code. And then for some reason, unknown as reason, it does this again. Okay. What does it do? Well, it makes another string, puts in um puts in, and I can remove all of that because this is not necessary anymore. String, it puts in RDI first. Argument says RDI, right? And what is RDI equal to? RX, which is equal to um so it puts in R the address of rbp underscore 40, and then it does the same shit. It uses data 00103008. Unless it's saying that um unless our RSI is null, right? RSI could be null, and then this string could be like a growing string. Yeah, right here. It uses sin on that. Okay. So it's just like makes a new string. Okay. And it passes in a actual allocator this time. It passes the allocator at RBP underscore 69. Um, just said that, and it calls the allocator new allocator underscore new allocator 6 RBP underscore 69. Okay, I'm starting to understand. So that right here, it didn't need this, right? Because it already had this. It's not gonna grow. So it just seems like a fodder. It doesn't need to, like, it's never gonna be calling the allocator function at all. So in theory, if I run this in Ghidra, right, and then I try to call like I try to like increase the length by calling a string function, but I would have to find the like string v table and everything for that, and that's like a lot of work. But maybe that's the dream. That's the dream. Okay, so it's just gonna pass in a fodder, and the same fodder is gonna use for this allocator because the compiler is nice because of the flags they use to make this like a better to make it read better. Okay, it passes in that, and then it passes in this, and then this, right, and then R whatever RSI is, right? Because doesn't it always need RSI? Oh, okay. This one does not need. This one doesn't always need RSI. Okay. Okay. So this one needs the allocator, and this one does not need the allocator. Now that's got me a bit confused. And I'm just going to say that this one actually does need an allocator, and that Ghidra is just stupid. Okay. And then what is it? Well, we're gonna write down RSI here as well, because actually no, we're not gonna do that. We're just gonna do this, and then we're going to mm, and then it loads in a string. So let's see, const char data underscore 001030, and then probably another 030, and then 20, 3020, okay, 20 equals uh console underscore writ crack crack me written console crack me written dot I realize I don't need this. Um, and then it loads into RX. So I'm just gonna address of count, std cout. I'm just gonna put that there, and then what's it do? And then RSI equals the data underscore 00103020. Just the yeah, is because that's a pointer. Yeah, this is loading it the address directly, the address of count, and then it moves into RSI that, and then it moves into RDI RAX. Okay, it moves into RDI equals RAX, which is the SCD and SS count, which is this address of that. Let's make some space here. Oh, by the way, this is like really long now. Okay. Um. Okay. And what's it do after that? It it calls. It doesn't call anything. Oh yeah, it does. It does call operator dash dash. So it calls operator, which is the stream operator or whatever. So it loads in RDI, which is the address of std count, and then RSI is equal to the data. So COUT is not the function. Well, it is the function, right? But it is the count, and then the data. And what else is it? RDX is used? No, RDX is not used because RDI just goes into RSI. Okay. Operator offstream param1, param2. Just two params. Okay. Okay. Now it's good. It's really good to like know the calling convention. It's like really helpful because now I can just like do that, and then I don't need any of this because I know that it doesn't like an offstream count and then that data. And what's it do after that? It loads into RDX the string enter password. Okay, let's define another data construct uh, data underscore 00103082 equals enter the password. Yep, this and a space. Um, yeah. Okay. Wait, I don't think there's any space here. Yeah, that's it. Um, so and then there's a it loads COUT into RDI again. So it loads COUT into RDI again, which was oh wait, never mind. Um, it calls that, and then because I was looking at it here, yeah, that's not it. It loads that into RDX, right? RDX equals data RDX equals data underscore 00102082, right? And then So I think this is important. Char, because then I think RBP 69 is like a char, right? It probably is, right? Yeah. Let me just do that. That. Okay. RDX is equal to that data, and then what else? And then it loads into RAX equals COUT again because it called the operator, right? And because RAX is not saved into the stack, so that's why it needs to do that. Okay, and then RSI. Okay, RSI is like a bit new right now. Well, I guess it was used like the last call, literally the last call, but sets it to RDX. RSI equals RDX. Okay, so every time I notice this pattern, whenever there's like a string, it loads first into RD RDX and then moves that into RSI. So I'm wondering, can't you do like can't you load string directly into RSI? Yes, you can load address of the string. You can, but the assembler just doesn't do it. Okay. That's like a thing I should recognize, I guess. Um and what else was he doing? Loads of that, loads into count, and then RDX, which is this data underscore 00103082, and no need for that. And then RDI is equal to RAX, which is equal to STD count, and it has to remake all of these because operator probably might have jumbled it up. Well, it doesn't care about jumbling it up. It's not gonna save stuff because these are all caller saved, right? And there's no reason to save all of these. There's no reason to waste like pop and push and stack space on these stuff. So I understand why um it would have to do this again. Enter the password, and then it calls operator again. Okay, so it calls operator again, and again std is POUT, right? And RSI equals RDX, so data underscore 103082. Um, no other register is used, so this is just it. So we can remove all of this now. Wow, it takes like a lot to decode like one function call. I guess it can be faster. I'm just like explaining it to myself and to like anyone watching and listening to my bullshit like explanations. I'm also saying like a lot, which is not good. So I'm just saying like I use pauses in between instead. If I had done my other channel today, then maybe I would have learned to not say like and not repeat my words like not like that. Don't stop stuttering, okay? I have to stop studying and I have to become more fluent with my English. Okay, so operator, and then it loads the exact same thing. No, it doesn't because I was reading here. And then it loads. Oh, okay. Wait, this seems to be. I recognize this. RAX is equal to RBP underscore 40, right? The rest of that, right? and RBP underscore 40. I remember that. This is a this is the string that can grow because it made a new allocator. Okay. 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 This is a string that can grow, and then there's a loads syn into RDX. This is kind of a special time because earlier the compiler was like saying RDX should be holding strings. Now it's saying that RDX should be holding the address and RDX should be holding the function call. I guess it has like priorities. If it's like a string, then it makes RDX hold that. If it's like a string or like a yeah, if it's like a string, then it makes RDX hold that. Because strings are data, right? And RDX is for the data register. But now functions are more of a data than the stack, I guess. Functions are like more predefined. The stack values can change, but functions can are like predefined. So in terms of that, functions are kind of like more of a data than the stack. So I understand why it might do that. Okay. So this is how I'm learning, bro. I'm learning. Okay. I'm learning the stuff. Um, what do I write? It's RDX, RDX, RDX. Yeah, can people hear me snap? No, because there's noise suppression. But what about now? What about now? What about now? What? What about now? What about now? Probably not. 'Cause I just snapped. I was just saying, what about now while I was snapping? If anyone didn't understand, if all of my 0 viewers are not understanding this, um, okay, so RAX is that. Now let's see. RDX is sin, right? Okay. RDX equals 80 sin. Uh, we can just honestly we can just do this. We can just operator because like we're gonna like look at this after operator. Let's just look at the function call. I think this is how you do it. Let's see. Well, we already know it kind of takes in like a like std sin, std cow or whatever like that, something like that, right? And it's just doing std sin. Um, and then std sin is an rdi, which is the first param of every function in this calling convention. So and then it's storing it rdx in there. Okay, so we can just put std sin, and then we can put, oh, maybe this can be my write up. This is my first write up. Like, does this count as a write up? Not really. I'm just kind of writing like C plus a bit of pseudo C. But it's not really pseudo C because all these things could actually be C code if I just define the right like things in here. Right things in here. I need to stop saying like. So I realized for the past 3 hours I've been like talking nonstop. I said like again. Are you serious? I said like again. Okay. Anyways, yeah. Oh, there's a fly in my room. Oh my god. Okay. whatever, STD sin, and it calls that, right? It calls, and then RSI is equal to RAX, and RAX stores 40 local 40 RBP underscore 40. So now we know that operator is calling sin and RBP underscore 40, and we know that sin takes in stuff, and we know that RBP underscore 40 is a buffer that can grow since it has a allocator assigned to it. Unlike the last string, the password string, as we know. And then we can just do this. Let's see. I'm getting a bit faster now at doing this, and this is also honestly kind of fun. I bet I wouldn't find this as fun if I couldn't talk over it like this though. Rx, and then it moves into RSI the value of Rx. Okay. It doesn't. Oh wait, I was looking right here, dude. I keep on looking like at the place that looking at the place, dude. I really have to stop saying like looking at the place that doesn't matter. Looking at the place which doesn't matter. Let's see. RDX is being loaded the address 60, which I also kind of remember. Wasn't that a thing? That used to be a thing. 60. Yeah, here. This was the this was this is a string. This is a string object, and it contains this string, and it can't grow because otherwise it would crash. This is a constant string object. So let's see. Since since we know that that's a constant string object, 60 is constant string object, and 40 is the growable string object. So what is it doing? Wow, I really wonder what it could be doing. Could it be comparing those things? Ooh, maybe. Okay, so let's see. Let's see. Dude, I have to stop using filler words like and ums and like. What am I doing? Okay. Anyway, sorry. Just for that, I have to do this. Peter Piper Ada. I forgot the name. Peter Piper ate a pickled pepper. Yeah. Peter Piper ate a pickled pepper. Peter Piper Peter Piper ate a pickled pepper up a batter pan. Peter Piper ate a pickled pepper. Ah 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 ah. Peter Piper Peter Piper ate a pickled pepper. Peter Piper ate a pickled pepper. Peter Piper Peter Piper ate. Ugh, I hate this. Peter 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 Piper ate a pickled cherry out of pickled bottle of water. What am I saying? Dude, this is supposed to be a learning hacking in today's day 11. Although I have 0 viewers, I'm going to entertain them. I'm very loyal to my viewers, okay? I'm the most loyal to my viewers, and my viewers, you will not be disappointed. This is my advertisement to my viewers. I might make a clip out of this because that can be considered like a tad bit funny, like low key funny. Okay, anyways, um, dude, I keep on using filler words. I just said again. Okay, RDX, RDX loads into RDX this changeable string. I mean unchangeable string. This is a constant string. And this is a string that we just took in the input from. So we can do that. We can do that. We can do that. Okay. It calls this operator. It first argument is Rx. What is Rx equal to? Rx is equal to 48. Okay. Opera. I wonder what this could be doing. Equals local not sorry, RBP address of RBP underscore 48, right? And then RSI is equal to RDX, and RDX is equal to this RBP underscore RBP underscore what is it? Oh no, I used the wrong thing. RBP. So that's the first one, right? And then after that, it's going to be, dude, did I say again? I'm not gonna say again. Okay, anyway, let's continue. I'm not gonna say again. Okay, let's continue. So, dude, I wonder like out of the 3 hours and 40 minutes that I have been streaming, almost 50. Okay, it's actually 3 hour, 40 minutes, and right now 50 seconds. It's been that long. Well, it was been that long. It's probably been 5 seconds past by now, maybe 10 probably now. So it's been about we can say about 3 hour, 41 minutes and 30 seconds. And out of those, I wonder how much time is actually me just talking on here instead of doing productive work. Okay, anyways, I hope this video can make great clips because I only have 3 clips in this channel and I need to make more. I don't even have a single subscriber yet. It's a bit sad because it's been like 11 days. I don't really care. I really hope people subscribe to me. Please subscribe right now. Please. Please do it. Please do it. Thank you. Thanks a lot. Thanks a lot, man. If you don't subscribe, I will hack you. I'm just kidding. I won't because I'm a noob. I can't even hack myself. How would I hack you? Okay, let's continue. All of my 0 viewers, are you ready? Did I hear yes? Okay, bet. Let's go. RBP underscore 40 and RBP underscore 60, right? It puts in RDX. Yeah, well, I keep on saying okay. Puts in RBP underscore 60, and now we are ready. It uses operator equals equals. That must mean that there's a result. Where could the result be? Ooh, what is this? Test? Ooh, okay. I forgot what test is again. Test in assembly. Bitwise and it discards numerical results and updates e flags. Check if SEX is set contains 0. Zero flag, sorry, flag. Overflow flag. Test the flags. In this case, test sets a 0 flag when the result of the AND operation is 0. Okay, got it. Why not just like, dude, I just said like again. Okay, I mean, that's a good way to test. Okay. I can allow because sounds more cool than sounds confident and thinking, while sounds awkward and a bit like you're unsure. So let's use So every time I want to say I'll just say This is a W stream. I don't care what anyone says. This is the best stream ever. This might be my longest stream as of now because it's been 3 hours 44 minutes, almost 45 minutes. Let's not get into the intricate details about the seconds and the exact minutes and hours that have passed because I don't want to discuss those intricate specific details to this computational neuroscience thing. I don't really want to be like that, like biology, medicine, like chronology in this ideology and the Schule of the police Shamale low is not slowly she. You understand? Yeah, I do too. Thank you very much. Okay. Operator equals test AL and AL. If it's 0, which means it's okay. Let's see the results of operator. Result. Sorry for screaming and sorry for saying sorry for saying and sorry for saying like. Sorry for using filler words. Okay. The results of operator equals. Results to indicate equality returns to if both values are equal, false otherwise. Okay. False means 0. Meaning 0. If it's 0, then it should fail. Alright. No, dude, I just said again. It jumps there. Let's just go. Oh, it's right here. Why was I inspecting so hard? Okay, so Lowe's address operator is not equal. Why is it checking if it's not equal to when it's already checked? It's checking is it equal to, and then it tests, right? And then it goes over here, and then it moves exact same values on here. Tests if it's not equal to. Bro, are you serious? What type of compiler is this? It's testing if it's equal to, and then if it's not, sorry. Oh my god. Okay, and then if it's not, then it jumps to see if it's not again. Otherwise, it goes here. Why does it go here? It goes here, right? And then it's, sorry for using filler words again. And then it loads into here, and then it calls string. It deconstructs the string if it is equal to after testing if it's not equal to. So let's clarify that. Let's clarify what just happened here. Right here, it tests is the two strings equal. If it's not, it jumps here. When it's not equal to there, it again loads those two strings, compares if it's again not equal to that, and then it says is it equal to after that? It's comparing if it's equal to. It's comparing if it's not equal to after just finding out that it's not equal to it. So why does it have to check again? And then after it checks, right? After it checks, it goes here. It goes here if it's not if it is equal to. But we already checked here if it's equal to, and if it was, then it wouldn't go here. So if it is equal to, it does this. It moves into EBX 00, calls deconstructor, calls deconstruction on the other string, moves into EAX the result of the value of EBX, and EBX should be unchanged, meaning EAX will now contain 0 because EBX doesn't change even between calls. This is the knowledge that is required for knowing how to do stuff in assembly. Calling conventions, knowing the calling conventions are really powerful. So I just want to emphasize that because right now, if I didn't know that, I would be searching why would it do this, right? I would be so confused. What is the point? I just know that it's moving 0 into it. And likely with these combination of instructions, rather than just moving 0 into EAX, maybe with these combination of instruction, now doing this is faster than just directly doing that. That's where I can understand it. But if it was doing something else, I mean, if I didn't know the calling conventions, then I wouldn't understand at all. I would think that EBX might be like a parameter, because why else would it be moving 0 0 into it, right? And string, this is probably, yeah, this just takes this, so then it deconstructs those things, and then yeah, there's more xrefs here, and then it moves here, subs here, jump 0. That means it should be safe, and then it exits the function. Otherwise, it jumps here to call stack check fail, which makes sense. Okay, that's simple. But what is here? It calls this again. It calls a new allocator for no reason. I mean, there might be a reason, right? But is this a loop or something? Shouldn't be a loop. And then it just calls unwind underscore resume. Unwind underscore resume. Sorry, I had to stretch. Okay. Okay, so it was this shit, right? I'm just assuming no, this doesn't matter because we basically have the thing, and right here it checks if it's right password. Yep, out, right passwords, call, operator, this, then it comes here, then it tests again. Like I don't understand why it wouldn't just jump over. I guess now I understand. Now I understand why it would test again because it's not really testing again. It's just it's just avoiding a jump instruction, and it's just directly. But that's so stupid because the jump would be faster. It has to call this function again. It has to call this function. It shouldn't need to do that. And if it was the right password, it just does that. And then if it was not wrong, if it was wrong, then it would call this, but it just jumps here. What is this? Okay, so it just deconstructs and then sets up a new allocator here again. Oh no, sorry. This is the deconstructor for the allocator. Oh, okay. Oh, okay. Now a lot of this stuff makes sense. Unwind underscore resume. I'm just assuming those are stuff for compiler and stuff. Okay, okay. I'll ignore that. Okay, well, we basically have everything down. It does that, right? It, what does it do? If EAX equals 0, then it then it means it's the wrong password. Then it compares. Then operator equal, not equals on this, comma, underscore 60. Again, if this happens, if ex equals 1, right? Is that what it does? Because it it jumps here. It basically just checks again. Then it's just going to return, or it's going to print that stdc out. It's going to print operator stdc out. It's going to print the data. So there's two datas here. Const chart data underscore, what is it? Right underscore right password data. Well, I shouldn't name it that. I should name it 0102097 equals right password const char data underscore 00103087 equals wrong password plus n. Oh, no, sorry, that's all password. And it just calls this 00103087 wrong password. Else is just going to call the right password operator std cout, give me the address instead of this, and right now it should be this, this, nope, 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 here. Hit that here. Now data underscore 001000103097, which should be the right password. Okay, and then the other shit, stack, canary check, subtract if fs is 27, right, 28 minus rbp underscore 20 is not equal to 0, stack check fail, return 0. Okay, well, we did it, guys. I didn't want to do that shit anymore. I mean, I did. This was fun, but I kind of decoded what that was. So this is fun, though. This is fun. I definitely got faster towards the end. I got faster with recognizing why the allocator is doing what it's doing. Also, wait, let me here, here, uh, here, right here, insert, and then allocator underscore new char. Should be this, I think. New allocator, and this should be the deconstructor. Where was the allocator again? It was something like RBP. It was actually RBP 069. Oops, sorry. 6 9 only. My voice just got really weird. Okay, RVP underscore 6 9 is the thing. Yep, it is. And yep, it does use that. Makes a new allocator here. Destroys allocator here. Okay. Wow, I really I like that. I like that. I got way better at doing this. See that? This is beautiful. This is actually so beautiful. Unwind or whatever, right? There's the thing. Unwind. It was after this, pretty sure. Unwind something. Should I say my first? My first right up WQ. Move this into move crack B's no letters dot C to crack to right up understood crack me no letters. Okay, now we can do this, guys. We can publish our write up. Let's go. Our first write up. Where's it at? Where's it at? Where's it at? Write up, write up, right here. Let's go. Give me write up. Submit a write up. Let's go. Let's go. Let's go. Where's my write up? Dude, what do you mean? 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 I mean I think they're not gonna accept my thing at all. Oopsies. Don't do that. Oh, I thought I accidentally put up my passwords on here. That'd be a bit bad. Okay, where is it at? Um, correct music dot. Dude, I want to keep going, but it's almost freaking 5. Correct music dot one. And my English got like weird. Like I was so chill at the start, but now this is what crack me's do. Never do crack me's, guys. Control H. Today, where's that? Where's it? Crack me's dot one right here. So that and now I can't even. It doesn't even matter because it's not gonna load in the same thing. Crack me's AI. No flop, no fake compressor, no hand holding. This is written by AI. There's no write-ups. Upload was upload was 2 days ago. That kind of makes sense. Might be a virus though. I'm just joking. I'm just sorry, Victoria and Mizla. It's not a virus. Victoria, Victor, Victor Melosum, Victor Melosum. ASM at the end. I'm assuming that stands for assembly, or that might just be your last name. Or it could be Victor, me, love, ASM. But there's no LOVE. So maybe you only half love ASM. Haha. Get it? Sorry. Sorry, Victor. Let's see. Search there. C++. This Linux. Search. Let's go. Nope. Difficulty between 1. Like, I want to try something. Something should be done. Download. Okay. quite a simple crack me. Okay, good quality. Honestly, I don't want to do. I think today that was good enough for today for ASM. Cause think about it. If I keep on doing that, it's already 4, bro. We're not gonna have time to finish this. Where's it at? C programming node.h. Okay, let's finish this, guys. Open it in mousepad. That's not good. Open with Vim. Oh yeah, I did it open in Vim. Okay. Okay, so what is the plan for this? What is exactly the plan for this, right? Define node h. Why is this so okay? Hashtag define that. It's so buggy, bro. Okay. Type def struct node as this. And I think the bug is due to the fact that I'm doing I mean it did already fix this tab for me. But yeah, it is true that there is like artifacts like that. What is this? Pretty sure this was a function, right? Now it showed up. What is going on? Is it because I was doing that? It doesn't seem like I was doing that though. And okay, so what was I doing? Was this ignore the couple of little small bugs, even though those are low-key big bugs that might mess up my whole code? So what is the plan? Well, we can create the node, and I'm planning this. Basically, if there's if there's we're just gonna do this. We're gonna so these two variables, the size holder and size limit underscore from. Size holder is gonna do this. So size holder is basically this is a boolean, right? And it's gonna determine is this type of size holder. If it is, it's going to check if this like well what this is, and this will contain the the how much in terms of how many nodes is it will contain how much more nodes until we have to malloc again. And if we check that the count until the last size holder is exceeds this amount, then we have to malloc. Otherwise, we can just keep on reusing the same thing. So right here, I'm going to do this dot r dot is size holder is a size holder. Maybe I should add a is size holder. Okay, is is size holder equals 1, because this will actually hold the size because this is the first node, right? And here it's going to do this for this one. It's going to first check the amount of nodes in total, and then it's going to do this again. It's going to check again, but this time it's going to do this int amount nodes 0 int last size order 0 node last size order equals 0 first. And instead of doing that, we can just do this. We can say if last size order equals 0, then we can keep on decrementing it. But why would we need? It's fine, I guess. Last size holder, and then I could just do C plus plus, C plus plus from there too, and amount nodes plus plus. Okay. If if the if last size holder is equal to 0, and and uh, and not sorry for studying, sorry for saying filler words. Okay, last size holder equals 0. Or wait, let's do this operation. What's it called again? A ternary operation. Okay, so what's the condition? N dot n is size holder question mark equals 0 question mark. Then we assign it to 0. Otherwise we assign it to n, and then it checks if it's 0. If it is, then it's going to plus plus. Otherwise, if it's not, then it's actually going to do that. So we have to do this. It's plus 1. Alright, and yeah, okay. And amount of nodes plus plus while n is not equal to 0. That one makes sense. Okay, yeah, that makes sense. And yeah, okay. So let's see. Well, the size int new size equals, it should be the amount of nodes currently times 2. It should be twice as big as that, and it should be times, well, the new size should be, yeah, so the new size should be able to contain this much, right? And then this should start from times size of node. This should start from the last holder. So n, what do we say? So just n, not no, I mean last size holder, right? And we say the new size should be from this. Yeah, so we should say that it should be from this. Okay, so yeah, okay. We have to do if the if amount of nodes plus 1 amount of nodes times size. Okay, you know what? I won't do that. I'll just do amount of nodes plus 1 times size of node is greater than or equal to last size holder dots. You know what? Instead of doing that, actually, never mind. Okay. Wait. Let's do this. So let's see. To up to the current size holder, how many counts do we have, right? We do that, and then we do times 2, so that now every single time the distance from the size holder is gonna be times 2. Every time we try to when we create a node and we're about to run out of space, then this is going to run, right? We're gonna create. So how much do we actually create? Well, we create the distance from the last size holder times 2, meaning, yeah, that's the meaning. So just that times 2, and then we create that amount of node. Or no, wait. We say the last size, we say the size is equal to the size times 2. Yeah, yeah, that's way better. Okay. U size equals last size holder dot, what was it? Size limit from, where is it at? Where did I put it? Okay, is it not here? Ugh, I think it was this, right? It's greater than, oh wait, it was here. Okay. Um, last size holder, not older. Holder dot, dude, is size limit underscore from. Size limit from. Size limit from. And then we just do that times 2. Alright, so that now every single time is going to be multiplied by a power of 2 times how many times we've already 2 to the how many times we've already had to increment the size. Okay, so let's do this. Are the previous size holder our last size from equals, let's put it as a solid 4 times size of node. Okay, and then we do, if amount of nodes is greater than that, then we just do last size holder dot, yeah, this is all amount of is greater than last Yeah, that's what I was gonna do. The size underscore limit. Yeah. Sorry for using filler word again. Size limit. It's been 4 hours 19 minutes. This is my longest stream by far. Size limit is greater than size limit. Right? Is that what it is? Size limit, yeah, it is from greater than or equal to that. Then it's just going to malloc. Malloc. But not just malloc. We're gonna assign that. Okay? So we're gonna assign that. What is it? Realloc. Realloc. What does realloc take? Realloc. Realloc. La 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 la. Realloc. Void pointer. Existing pointer returns the pointer to a new memory block. What's it do? Does it free? Oh, okay. That won't matter to me. We're gonna have enough RAM, okay? So what is it? You just have to buy RAM if your malloc fails. You can't do anything about it. Okay, let's see. Realloc. The pointer was head, which should be N, and then what else? Plus equals. Or no, minus equals, because that was still, that would be the top of the thing. That would be like the tail. I said like again, bro, come on. Well, it wouldn't, it should be called the tail, right? Because it would, it's being appended to it. It's not, it doesn't, it's not the start of it. That's fine, I guess. Well, I guess I can call it the head. Realloc N. Let's do this. N and the new size. New underscore size. New size. Yeah. What is it? You know what? Nah, there's no memory error, bro. Yeah, trust me, there's no error. Unless there is, and then in that case, I'm wrong and I'm stupid. Okay, so this is it. We just have to do this now. What is search ID? Well, we already have this. So now we could just right after n we're gonna assign. So we're gonna end equals n plus size node, and we're gonna create what is it? ID. Okay. And but we can just copy the below code, but my copying skills in this editor are really bad. You could probably, if anyone is watching, you could, no one is watching, but I'm just saying, you could see that from 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 the time I got Vim up till now, I just feel I'm terrible at it. I didn't doing that. I was just copy that. It's gonna take so much more time than doing this, and the typing won't even take that long. Cause at some point, I keep on starting, but at some point there was no typing, right? I mean, there's no copying, so everyone had to type by hand. Because if it's a feature, then it was added later. It's not the first thing that exists. So at some point, people had to do that, and at some point, people even had to make holes and stuff. Last size from equals new size. Okay, that's all. Basically all. Now search underscore ID head equals head equals. Dude, I was thinking like binary. I said like again, but I was thinking binary search in this instead of linear search. So it would be like, oh my god, I said like again. So I would like, oh my god, like again. Oh, yawning. It's already 5 now. So I was thinking binary search in this, and I know that binary search works. I'm like, you have to find a. Yeah, I don't know. I don't know how it works honestly. Head equals head equals head minus size of. Because I don't want people to save the head. I just want them to save the last thing that they added to the thing. Now, now this is good. So let's see. Cache equals cache head equals temp. If head dot. Well, how is binary search supposed to work? It's supposed to, and cache count doesn't exist anymore. So how is it supposed to work? Well, it's supposed to be. It's supposed to be. Okay, so basically, pretty sure you need a. So you just need to go to the. So yeah, first you do need the size at first. Yeah, you need the size, and then you just check if is it equal to is it equal to 0, or well until you find it, right? Is it equal to, well, you need 2 pointers actually. You need a left equals 0 and r equals 0, and you have to do this while L equal to r less or just less than r, because when it's equal then it's equal, right? And I have to basically return the index too, but I'll figure out how the indexing works because I'm not sure whether I want to subtract or add. But I want to do this. So R will be equal to the count, and L will be indeed 0. And if L at if if times head times L, I feel like this should start at 1 because that's just going to mean nothing. If I do head times L, that's just nothing. It shouldn't be head times L, it should be head plus L times size of node, or head minus this. So then this would be the leftmost, well, basically this would be the rightmost index. I'm not gonna say I guess because that's a filler word. So I should do rather left is greater than right, because right will start at the count, and head minus the count would give me the leftmost index. So actually, let's, instead of doing that, let's do L equals C and R equals 0. And while L is greater than R, then do that. So head minus L. So yeah, head minus this is, and then we have to dereference this dot id is less than less than head minus L. Head plus L. No, wait. Yeah, head minus R. So if this side is less than that, if this side is less than that, then that would mean that to the far left is 0, and that to the far right is greater. So we would need to, I'm really stupid, bro, because I need an ID. int ID. Yeah, okay. Now finally we can search for ID. Is less than, if ID is less than this now. If ID is less is greater than ID, that would mean that ID, then that would mean that the L should increment, or no. If this is less than the ID, then that would mean that L should increment. And in this function, I'm going to add a sort method that will basically sort here at the end, and I'll just provide it the values, in which case I should probably just have a node result right here. So node result, and this is what I'm also going to return. That would be the last thing on the list. So I'm just going to return result equals R. Result equals, basically I'm just gonna finish the binary search today, and tomorrow I'll implement the sort, and I'll do a merge sort for this. So L plus plus, which means that since this is really low, I should probably increment the left pointer because it's much slower, right? It's much slower than the ID that I need to be at, so I should increment it, and which means it will be closer to R. So we should add a if, but that won't make sense though. That won't make sense right now. If head, so we're just gonna do else if head minus R times size of node dot ID is greater than is less than. So R shouldn't be less than the thing ever. So it's greater than ID, right? Then I should. So if ID is less than this, so if ID is yeah ID is greater than this, then L should increase. It's less than this, then L should increase. Otherwise, and then R plus plus. No, this isn't how I was supposed to do it. I was supposed to look at the middle. Yeah, I was supposed to look at the mid index equals 0 equals L plus R mid index divide equals 2. Yeah, I was supposed to look at the mid index minus mid index minus mid index, and then I have to do mid index divide equals 2. I just have to return mid index is is greater than the thing. Otherwise, this is going to break. So here it's going to decrement the R pointer, because if you think about it, oops, mid index equals R plus L. If you think about it, mid index is R plus L, right? So I'm going to be decrementing L if so that I can get closer to the higher values, because it seems that right now the mid index is really low, and if it's much if the mid and oh my god, if the mid index is much lower, then I'm going to be adding to R. I mean, if the mid index is much greater, then I'm going to be adding to R, because it's going to check. Yeah, so this should work right now. And I know it's not going to work because I wrote this code, right, without any instances, so I know there will be bugs. So now that is all for today, guys. We did a decent amount. Save. We did pretty good. We did a decent amount. What did we learn today? We learned that well today we learned that RDX typically will point to data-driven values. I'm not sure what else to call it, but to constants RX point. Actually, no, no, that knowing that me- memorizing calling conventions are important stuff such as and where the C starts, stuff like that. Still need to learn how to get draw to do stuff properly. Okay, that's all. Okay, thank you guys for watching. Thank you my 0 viewers for watching. Let me chat. Let me say yay. Let me pull up the chat on here. Close this. Close this YouTube. A worst programming language? Yeah, you're right. Bro, I had to debug that shit. You guys can see I typed yay. Let me type it better. All uppercase. Do it 3 times for good luck. W. Okay, guys. That's all. Thank you.